In some books, they do not make the difference between delta G and delta G0. And if you look, for example, to the reference uploaded in the class material, which is Zumdal book, he did not make the difference between delta G and delta G0. He used delta G0 to predict the spontaneity. Pay attention, in our curriculum, we have to make difference between delta G and delta G0. Delta G is directly related to the spontaneity, and next we will see that delta G0 of the reaction is directly related to the equilibrium constant of the reaction. So it's related to the advancement. In some exercises, we can write delta G equal delta G0. And this is only when the reactants and the products in the described exercise are in their standard state. At temperature given, the partial pressures of gas, for example, a reactant in a product is 1 atmosphere. If you have ions in reactant or products, the concentration should be 1 molar. So delta G is different from delta G0, but in some cases you can write delta G equal delta G0 only when you are sure that your reactants and your products are in their standard state. Under non-standard conditions, delta G is different from delta G0, but we have a relation. I will not prove this relation. You can use it directly. Delta G of the reaction is equal to delta G0 of the reaction plus RT ln Q. Pay attention that when using this formula, delta G, delta G0, and the temperature you use should be the same. Delta G and delta G0 should be at the same temperature you write in the formula. You can write, for example, delta G 298, delta G0 298. You have to use temperature 298. You can use delta G 500 equal delta G0 500, but you have used the temperature in the formula 500. So delta G equal delta G0 plus RT ln Q. Delta G0 is the standard free energy of the reaction. This is the identity of the reaction, and it's always known or given. R is the ideal gas constant given in joule per mole per Kelvin, 8.314. Temperature is T is the temperature in Kelvin, is the temperature of the reaction in Kelvin. So now we have to define Q. What is Q? Q indicate the advancement of your reaction. You are at the beginning, in the middle, in course of the reaction, at the end of the reaction. So Q is an indication about your advancement. And the Q is called the thermodynamic ratio or the thermodynamic quotient of products and reactant. And the Q is equal always products divided by the reactants according to the stoichiometry. I will give short notations about the Q and K studied in the equilibrium chapter in the college in grade 12. Suppose you have a reaction AA plus BB that gives CC plus DD. In thermodynamics, the state of A, B, C, and D should be written correctly. The state of A, B, C, and D are very important in writing the expression of Q and K. Q is the thermodynamic ratio in course of the reaction. K is the thermodynamic ratio at equilibrium. For liquid and solid, use the term 1 in the expression. Okay. For concentration, or for ions, use the term concentration. For gases, use the term pressure. Example. Suppose I have a reaction A aqueous plus B aqueous, C aqueous, D aqueous. Q is the ratio of the products divided by the reactants according to the stoichiometry A, B, C, and D. But what term should be used? Ratio, concentrations, ratio of pressures. Since A, B, C, and D are ions, so I have to use the term concentration. Q equal the concentration of C to the power C times the concentration of D to the power D divided by the concentration of A to the power A times concentration of B to the power B. Since A, B, C, D concentrations depend on the time of the reaction, depend on the advancement of the reaction, so Q is variable. Q is variable. In the question, they should determine at which advancement we have to calculate a Q. What is the difference between Q and K? Q is the ratio at any time of the reaction, at any advancement of the reaction. One of these times or one of these advancements is the equilibrium state. So at equilibrium, we replace Q by the term K in order to say that we are at equilibrium. So K equal the concentrations of C, D, A, and B, the ratio according to the stoichiometries, but these concentrations are at equilibrium. Suppose I have another form of the reaction. A is ion, B is solid, C is gas, and D is liquid. By the same way, for liquid and solid, use the term 1. For concentrations, for ions, use concentrations. For gases, use pressure. So Q equal the C is a gas, I use the pressure of C to the power C. D is liquid, I use the term 1. A is ion, I use concentration of A to the power A. B is solid, I use the term 1. So Q depends on the conditions of the advancement. It depends on the pressure of C and the concentration of A only. Now, how to write the equilibrium constant K? This is the same term, the same expression, but you have to pay attention that the pressure of C should be at equilibrium and the concentration of A should be also at equilibrium. This is the difference between Q and K. Q is variable. It depends on the advancement of the reaction. Between brackets, the term advancement, the time of the reaction. After 1 minute, 2 minutes, 3 minutes, 4 minutes, 5. The advancement at 1 minute is different from that at 2 minutes, at 3 minutes. So I use in this chapter, I use only the term advancement because in the next chapter we will talk about the kinetic. So Q is variable. K is constant. K is the value at equilibrium. So what is the relation between Q and K, between delta G and delta G0? The relation between delta G and delta G0, delta G equal delta G0 plus RT ln Q. This relation can be applied at any time of the reaction or can be applied at any advancement of the reaction. One of these times or one of this advancement is the equilibrium. At equilibrium, we defined previously when delta G equals 0, we are at equilibrium. So if we suppose our reaction reached the equilibrium, that means delta G is equal to 0 and the Q is replaced by K. So the relation is 0 equal delta G0 plus RT ln K, and therefore delta G0 equal minus RT ln K, or K equal E minus delta G0 divided by RT. This is a very important formula. Delta G is an indication about the spontaneity of the reaction, and the term spontaneous means this reaction is possible or impossible at the given conditions. Look to the relation of K. K is directly related to delta G0 and not to delta G. K equal E minus delta G0 divided by RT. Pay attention when using this formula. Delta G0 should be at the same temperature mentioned in the formula. How to calculate now delta G? Delta G0. To calculate delta G, we can apply this relation. At any advancement, we know Q. Delta G0 should be given or calculated, so we can calculate delta G. Now, how to calculate delta G0 of the reaction? Delta G0 of the reaction is identity of the reaction and can be calculated by different ways. One, by algebraic method. We have some reactions of given delta G0. We make a combination in order to obtain the global reaction, and delta G0 global is the combination of delta G0 of reactions. Why we can apply the algebraic method? Since delta G0 is a state function. The method number 2 is to apply delta G0 of the reaction equal delta H0 of the reaction minus T delta S0 of the reaction. And pay attention that delta G0, delta H0, and delta S0 should be at the same temperature mentioned. So if we have delta H0 of the reaction at temperature T, and we have delta S0 given of the reaction at this temperature T, we can calculate delta G0 directly by this combination. The method 3 is to apply delta G0 of the reaction as Hess law for delta H equal delta G0 of the delta G0 formation of the products minus delta G0 formation of the reactants. And what is delta G0 formation? Is the standard free energy of formation of compound and is given in tables. So delta H0 formation is the enthalpy to form 1 mole from its simple elements at the standard state. Delta G0 formation is the standard free energy to form 1 mole of compound from its simple elements at the standard state. So delta G0, in any problem, they ask to calculate delta G. First, we have to calculate delta G0. And delta G0 of the reaction is calculated independent of the exercise. Okay, since delta G0 of the reaction is identity of the reaction, we can calculate by one of the 3 methods. We put delta G0 in its value. We know Q in the exercise. We know the temperature, so we can find delta G of the reaction. So the value of delta G0 of the reaction indicates in which direction a reaction is favored. No relation with the spontaneity. The term favored means this reaction is advanced or not advanced. So the yield of this reaction is high or the yield of this reaction is low. Delta G0 is related to the equilibrium constant. If delta G0 is negative, means K is greater than 1, that means we have more products than the reactants, so the reaction is favored in direction 1. We talk about yield, we talk about advancement. If delta G0 of the reaction is equal to 0, K equal 1, so we have balance in between the quantities of reactants and the product. And if delta G0 of the reaction is positive, means K is less than 1, so the reaction is favored in the direction of reactants. Two different meaning of delta G and delta G0. Delta G0 negative is related to the advancement of the reaction. Is this reaction favor products or reactants at equilibrium? But the term delta G negative means the reaction is spontaneous in the forward direction. I pass to example 6.5. One method for preparation of methanol involves this reaction. CO gas plus 2H2 gas gives CH3OH liquid. Calculate delta G at 25 degrees. Pay attention for the question. If he asks to calculate delta G, he has to determine the value of Q, or he has to determine the advancement of the reaction. Calculate delta G for this reaction where carbon monoxide at pressure 5 atmosphere and hydrogen 3 atmosphere. They give the advancement. The pressure of carbon monoxide is 5 and the pressure of hydrogen is 3. And he gave delta G0 formation of the products and the reactants. So we have to apply the relation delta G at T equal delta G0 at the temperature T plus RT ln Q. The temperature in this exercise is 298 Kelvin. So delta G at 298 equal delta G0 at 298 plus R, the temperature 298 ln Q. To calculate delta G at 25 degree or 298 Kelvin, we have to calculate delta G0 at 298 and we have to calculate Q in the exercise. Apply delta G of the delta G0 of the reaction equal delta G0 products formation minus delta G0 formation reactants. So equal delta G0 formation CH3OH liquid minus delta G0 formation CO gas minus 2 delta G0 formation H2 gas, and the values are given. So we calculate delta G0 of the reaction. Now we have to calculate the Q. Q is the ratio between the products and the reactants at the given advancement. And pay attention, since CH3OH is a liquid, we use term 1. CO gas, we use a pressure. H2 gas, we use a pressure to the stoichiometry 2. And the pressure of CO is given 5 atmosphere. The pressure of H2, 3 atmosphere. So we calculated Q. Now we apply the relation delta G equal delta G0 plus RT ln Q. We put delta G0 by its value and pay attention that delta G0 is in kilojoule. You have to transform R to kilojoule, or you transform delta G0 to joule and R remains in joule. So we do the calculation and we obtain delta G equal minus 38 kilojoule. What is the meaning? The meaning that at the given conditions, the formation of CH3OH liquid from CO gas at 5 atmosphere reactant with H2 gas at 3 atmosphere is a spontaneous reaction. Suppose you mix CO with H2 at different pressures. It's not necessary that you obtain delta G negative. Maybe you obtain delta G positive. So you can say at the given advancement, at the given conditions, our reaction is non-spontaneous. Example 6.6, consider the following reaction. What is the value of K for the above reaction at 25 degree if delta G0 formation equal minus 11.2 kilojoule per mole? Pay attention. He asked about K at 25 degree. We apply the relation. We apply the relation K equal E minus delta G0 divided by RT. And since the temperature in the exercise is 298 Kelvin, so delta G0 in the expression of K should be at 298 Kelvin. So we have to calculate delta G0 298. We apply delta G0 298 equal delta G0 formation products minus delta G0 formation reactants according to the stoichiometry. We put the value in, we put delta G0 by its value found, divided by R. Since delta G0 is in kilojoule, you have to transform R to kilojoule. You multiply by 10 minus 3, and the temperature is 298. So we obtain a value of K equal 1.19 10 minus 4. What is the meaning of this value? If the value is low or high, there is no relation about the spontaneity, since K is related to delta G0 and not to K. But look to the value of K. The value of K is very low. That means the yield of your reaction is very low, or the advancement of the reaction is very low, or you can say that your reaction is not advanced, or in other terms, you can say your reaction is limited. So what is the meaning of K? If K is low, the reaction is limited or is not advanced. If K is large, the reaction is advanced. Temperature dependence of K. Since delta G0 depends on the temperature, and one of the main problems in the written of the formula Ke equal minus delta G0 divided by RT is to use delta G0 at the same temperature in the formula. Since delta G0 is temperature dependent, so K is temperature dependent. And we know that delta G0 equal minus RT ln K, and delta G0 can be written as delta H0 minus T delta S0 of the reaction. So ln K equal minus delta H0 of the reaction divided by RT plus delta S0 of the reaction divided by R equal minus delta H0 of the reaction divided by R 1 over T plus delta S0 divided by R. Look to this relation. As the temperature increase, as the temperature is variable, K is variable. So K is temperature dependent. For any temperature T, you have a value of K. So, for example, suppose you have a table given where you have the value of K for any temperature. You have two columns, temperature and K. You can write the variation ln K as a function of 1 over T, and this is the equation of a straight line y equal ax plus b. So if you write the variation ln K as a function 1 over T, you should obtain a straight line. The slope of the line is equal to minus delta H0 divided by R. The last point is that delta H0 and delta S, delta H and delta S and delta G depends on the temperature. But in your curriculum this year, we did not study or the variation of the thermodynamic data, delta G, delta H, and delta S as a function of the temperature are not requested. So when we use this formula, we suppose that delta H0 and delta S0 are temperature independent.